Precipitation reactions. Precipitation reactions are double replacement reactions where one of the products forms an insoluble compound, removing ions from solution. So double replacement reactions are reactions where we mix two aqueous ionic solutions and the cation of one combines with the anion of the second, and cation of the second combines with the anion of the first, creating two new compounds. This happens if one of the products is insoluble, if it forms a precipitate. So to identify that, we need solubility rules. Compounds, ionic compounds containing alkali metals, the ammonium ion, are soluble. Compounds containing the acetate ion, C2H3O2-, are soluble. Compounds containing the nitrate ion, NO3-, are soluble. These don't have any exceptions, and these overrule the later, primarily insoluble rules. The halide ions, these are generally soluble, except for halides of silver ion, mercury 1 ion, and lead 2 ion. Compounds containing sulfate are generally soluble, except for compounds containing strontium sulfate, barium sulfate, calcium sulfate, and lead 2 sulfate. Compounds containing carbonate are generally insoluble, and these will have the exceptions that were listed up here, the ammonium ion, alkali ions, and also the hydrogen ion. Compounds containing chromate, CrO4 2-, are generally insoluble except for alkali metal chromate, ammonium chromate, and hydrogen chromate, chromic acid. Compounds containing phosphate ion, PO4 3-, are generally insoluble except for the alkali metal phosphates, the ammonium phosphate, and hydrogen phosphate, which is phosphoric acid. Compounds containing sulfide ions are generally insoluble, except for the alkali metal sulfides, ammonium sulfide, calcium, strontium, and barium sulfides. And compounds containing hydroxide ion, OH-, are generally insoluble, except for the alkali metal hydroxides, ammonium hydroxide. And then calcium, strontium, and barium hydroxides are slightly soluble. So when we have a reaction, we look at the possible products that are formed. So we're going to combine, for sodium chloride with potassium hydroxide, we're going to combine sodium with hydroxide, potassium with chloride. So we have KCl plus NaOH. We check the solubility rules. You see that both compounds containing potassium and sodium are both soluble. So these are both aqueous. So this is no reaction. We need at least one precipitate to have a reaction. So calcium chloride with sodium carbonate. We're going to put calcium with carbonate. Calcium is a +2 charge, carbonate has a -2 charge, so it's a CaCO3. Then sodium with chlorine. We're not going to bring along these subscripts, they are not polyatomic ions. So we have NaCl. The two will end up in balancing the equation in front of the sodium chloride. Sodium ions we know form soluble compounds. Carbonates are generally insoluble. Calcium is not one of the exceptions, so this will form a precipitate, forming a solid. Calcium nitrate with sodium phosphate. We're going to do calcium with phosphate. To do that, we have to know that calcium has a +2 charge. We see that in that subscript 2 on the nitrate. Phosphate has a 3- charge. We see that at the subscript on the sodium. So, switching the charges as subscripts on the opposite ions, we have Ca3PO4 2. Then we're going to form sodium with nitrate, and again we do not bring these subscripts along. They're not polyatomic ions, so we have sodium is a +1, nitrate is a -1. So we have a sodium nitrate. The equation is not balanced yet, but first we want to identify if there's going to be a precipitate. Sodium compounds and nitrate compounds are both soluble, so this is aqueous. Phosphate compounds are generally insoluble. Calcium is not one of the exceptions, so calcium phosphate will be a precipitate forming a solid. silver acetate with potassium chloride. We're going to do silver with chloride. They're both charges of 1, so we have 1 of each. Then we do potassium with acetate. Potassium compounds are soluble, acetate compounds are soluble, so this is a soluble compound. Chloride compounds are generally soluble except for silver, mercury 1, and lead 2. So this is a insoluble precipitate, a solid. So this is how we do the double replacement reactions. The final step would be to balance them. To balance this one, we do 3 calciums. We have 2 phosphates. That gives us 6 sodiums, 6 nitrates. So 6 sodium nitrates.